I think I am live now. Yeah. Hello everyone. So now I'll teach you about the 12th chapter of our NCRT, which is electricity. Before we start further studying what electricity and how it is important in our daily life, let's come to something by which we can easily understand the topic and the chapter be further moving. Okay, so before understanding that what electricity is and anything, just start with taking some normal example, some day-to-day life example. For example, uh, when we switch on, on the switch, then we will know that we can easily turn off our fan and electric bulb and lot of things we use in our daily life like mobile phone, laptop, tablet, and my laptop on which I'm recording this, and everything which runs on lot of things are non electricity. So we are some familiar with that topic, but we don't exactly know what it's mean and how it affect our daily life, and how can we understand that. So before learning electricity, or before reading about electricity, first we will know about the electric current. What electric current? And before electric current, we will first study about what actually current is. What this term mean in real. Actually, current is of lot of types, and in easy language, I can tell you that current is flow. Flow, anything that can flow, or anything which is moving, we can say that it is current. For example, when water is moving in a river, then what we will say, we will say that it is water current. And when wind is flowing, and wind is also moving now, then we will say that what, it is wind current. And wind current, water current, water current, like anything. Sorry, I just write the spelling of water wrong. Yes, water, yeah. So anything which is flowing is known as water, is known as current. Like for example, if just we just take an example, if I'll take an example of the boys or the students which are running through a window continuously, then I will say that it is known as student current. Student current, yeah. So anything that flow, we will say that it is current. Okay, I think you will guys understand what actually current means. So now we come to know what electric current is. uh, yeah, what electric current is. Okay, so when, okay, now I will tell you what for, after that you will know about current. Now I'll also tell you about charge, or I can say electric charge. Okay, so we know that there are two types of charge, positive and negative. We will say when electron is present somewhere, then we will say, what we will say, it is negative charge. And when electron is absent somewhere, then its deficiency create a positive charge there. We know that. Okay, and we know that when in an atom, electron goes from like this is an atom. Oh, sorry, my, like this is an atom. When electron is move away from there, then a positive vacancy is created, then we will say it is positive charge. And where the electron goes, we will say that it is negative charge. Negative, negative charge. Okay, yeah. So these are two types of charge. Okay, now let's understand what actually electric current is. We understand everything before understanding the electric charge. Now let's come what electric charge or electric current is. Okay, let me, yeah. electric current is. Okay, so now as I already told you that flow of anything is called current. So when it comes to electric current, I will say flow of electric charge. It means that when an electron moves from one place A to B, then I will say that electron is moving. Then I will say electron is a charged particle. Then I will say that it is electric current. Okay, so I'll again tell you what electric current is. When electric charge is flowing, then we will say that it is electric current. For example, when we switch on, when we on the switch, then when we on the switch, then what we will have, what will happen? Let it be a switch at point A, and here a point B. Where is the, where is our bulb? Okay, this is our bulb. Okay, so when I on this switch, what will happen? A electron from point A just start moving towards point B, and when it reach point B, then I will say that from here A to B, an electron move from A to B, then what will say, what I will say, that charge is flowing. And we know that when we already know that the flowing of anything is called current, and here charge is flowing, then what we will say, it is electric current. Okay, I hope you understand. So I'll conclude the whole thing which I teach you in just one line, that flow, what electric current is. Electric current is, what electric current is, flow of electric charge is known as electric current. Okay, yeah, generally only electron can flow, because atoms have lots of free electron, and only positive charge created when there is a deficiency of electron. So when an atom who has deficiency of electron, then a positive, whole positive charge is created on that atom, then we'll take that atom as a positive charge. So we know that atoms can't flow from here to there, then what we will say, that we will only take that electron will flow from here to there. So it is called electric current. Hopefully you understand that flow of electric charge. The main thing about the electric current is it is the only known as flow of electric charge, and flow of electric charge, we will say flow of electron is called electric current. Like in this like right now the page on which this formula is showing, here is I, which denote electric current, or we will say only current. Electric, yeah, like I just right now I told you that flow of electric charge is called current, and when we take it in particular time, then we will say that flow of electric charge per unit time is known as electric current. Like when we take time also, yeah, we represent charge, electric charge, with Q, charge, or I can say electric charge, electric charge. So I'll represent it with you. So what our definition said, that current or electric current is the rate of flow of charge. It means that at how much rate, at how much fastly or slowly our charge is moving. If our charge is moving slowly, then we will say that our current is weak. And when charge is moving very fastly or rapidly, then we will say that our current is high or current is strong. So current I is Q by T, where Q is electric charge. Electric charge divided by time taken. It means that how much time is taken by that charge to reach from point A to point B. And we will say that it will be the value of current from point A. Let it be a point A or it be a point B. Then I will say that it is the value of electric current from point A to point B. I hope you understand. And how we will calculate this q is electric charge, and which is equal to number of electron. Like when number of electron are flowing, electric charge is basically the electrons. The more number of electron are flowing, the more charge. So we will say what electric charge is number of electron, like electron has a charge multiplied by number of electron divided by time. So it is called I, means current. And here is written also written the SI unit of electric charge is coulomb. We will measure electric charge in coulomb, which is equivalent to charge contained by nearly 6 into 10 to the power 18 electron. And how we will calculate that? We know that the charge on the electron is 1.6 into 10 to the power minus 19 coulomb. Coulomb is the unit in which we will calculate the electric charge. Okay. And if so, according to this formula, we hope you understand that this is the charge on the electron. Okay. So if according to the standard formula, if I will define this formula right now, then what I will say that 1 ampere. Oh, I forgot to tell you that current is measured in ampere, and charge in coulomb, and time in second. So how I define standard current, which is equals to 1 ampere. How I'll define you? I'll define you as when 1 coulomb 1 coulomb of charge, sorry, I'll write here, when 1 coulomb of charge is flowing through is when 1 coulomb of charge is flowing through 1 unit or 1 second, in 1 second, through any conductor or anything. Then what we will say that 1 coulomb of charge is flowing in 1 second, then I will say that 1 ampere of current is flowing. So this is the standard definition. When 1 coulomb of charge is flowing in 1 second, then we will get 1 ampere of current. And the ampere is unit of current, and it is given in the like here is written as the scientist name Andre Marie Ampere. It is given on a name of French scientist who has a lot of contributions in science and in the field of electricity. So we will give his name as a unit of current. So we will remember the scientist and the uh, uh, achievements and the things he's already done. Okay, so it is the here is also written the 1 ampere is constituted by the flow of 1 coulomb charge per second. It means that when 1 coulomb of charge is flowing in 1 second, then we will get 1 ampere of current. Actually, there are also many other smaller units of current which are milliampere, which we will measure in MA, which is 10 to the power minus 3 ampere, and microampere, which is 10 to the minus 6. These are the other. And yeah, the most important thing is that the instrument which measure the current is ammeter. AMM. It is also written as. So the instrument which measure current is known as ammeter. Sorry. So now I will tell you or conclude you the whole thing which I teach you right now is that starting from electric current, that rate of flow of electric charge is known as electric current. And yeah, we know that the current is the flowing of anything is known as current. When it comes to electric charge, then we will say when electric charge is flowing, then we will get electric current. Okay. Yeah, so electric current defined as the rate of flow of charge is known as electric current. And from there we can constitute a formula also. Rate of flow of charge is denoted by q, and time is denoted by t. Rate is denoted by q by t, which is equal to I, which also known as current. And we will measure charge in coulomb, time in second, and current in ampere. So here is the thing. And 1 coulomb contain charge. 1 coulomb has charge 6 into 10 to the power 18 electrons, which is equivalent to 1 coulomb is equivalent to, yeah, this value. It is also written here. Oh, sorry. It is also written right here, 6 into 10 to the power 18 electrons. 1 coulomb of charge is equivalent to 6 into 10 to the power 18 electron. And how we will get this value? The charge on an electron is minus, negative, or means negative, because we will take proton as a positively charged and electron as negative charge. There is nothing related like heat each has negative power. No, it only just we will take electron as negatively charged and proton as positively charged. So it has charge of 1.6 into 10 to the power 19 coulomb. Yeah, and we will take is like 1 electron is equals to 1.6 negative. Okay, where is my eraser? Just write down right here. Like 1 electron is equals to negative 1.6 into 10 to the power minus 19 coulomb. Okay, so rate of flow of charge is known as electric current, and which is equal to, here is a formula of electric current. Yeah, I is equals to q by t. I is the denotation of electric current, and q is the denotation of our charge. T is the denotation of time. Unit of charge is coulomb, time second, and I ampere is known as current. So I hope you understand there. And yeah, there are a lot of many smaller units of electric current which are milliampere and microampere, and then so on, and also the bigger units which are mega ampere, gigampere, and so on, from going small to large. And yeah, also the instrument which is used to measure electric current is known as ammeter. Like, okay, I'll tell you what this whole diagram, and also revise you the whole concept, so that you can easily understand what I'll teach. Here is a battery which we will use as a source of current. From here electrons start flowing and current start flowing in this direction. Like you will see, like arrows are moving, and I is a symbol of current right here. So electrons are moving from this point in this direction to like this. Here is the ammeter which is used for measuring electric current, and the electron are coming back. Here is the key, or we will say that is the switch. Yeah, the one thing which is important to understand is that electrons always flow from negative to positive. Electrons are flowing in opposite direction of current. Always electrons always flow from negative, from a point to b point. Electron always flow from a to b, like in this direction electrons are flowing. In this direction electrons are flowing in this direction, from here up and down. And current is flowing from b to a. So always remember that direction of electric current is opposite to the direction of flow of electrons. So the direction of electric current is always opposite to the direction of flow of current. Now question arises, why is this? Why is this happen? Actually, current is a lot of time. Current is a already current is many time before invented. Current is invented discover, sorry, I'll use the word discover a lot of time before actual electron, and at that time we will take that flow of current is from positive to negative. We will what we will take from positive to negative, which is always so. But after that, when electrons are discovered, we came to know that electrons are flowing from negative to positive. Yeah, so just to avoid the confusion, scientists use this the standard notion like current flow always from positive to negative and electron from negative to positive. There is no rocket science in that. Okay, so hopefully you understand whatever things I'll teach you till now, and this is for this is whole for today. And yeah, so this is what I'll teach you today. Thank you.